Well, how do those atoms stick together in a compound? The atoms are held together by chemical bonds. There's different kinds of chemical bonds that we're going to talk about. The chemical bonds basically result from the attractions between the charged particles that compose atoms. We discussed how atoms are formed from electrons and protons and neutrons. The neutrons are neutral, so they don't really get involved in this. But the electrons are negative, the protons are positive, and so all chemical bonds are some type of an electrostatic attraction. We can divide them into two broad categories: ionic bonds and covalent bonds. Ionic bonds are going to occur between a metal and a non-metal, and they involve the transfer of electrons from one element to another. Okay, so transfer is a very important word for ionic bond. Remember, we said that metals tend to lose electrons, non-metals tend to gain electrons. So you get a metal and a non-metal together. The non-metal will give one or more of its electrons to the non-metal. That forms ions. You've got a positive ion and a negative ion. Opposite charges are attracted to each other, and the attraction between the opposite charges is the ionic bond. It's an electrostatic force. If we look at the solid phase of an ionic compound, what we see is it's composed of a three-dimensional lattice, an array of alternating cations and anions. I think we have here's a picture. Okay, so here is sodium, the element, a bunch of sodium atoms. Here's chlorine, the element, a bunch of sodium molecules floating around. And what happens is this neutral sodium atom will donate an electron to a neutral chlorine atom. Then the sodium atom becomes a positively charged cation, and the chlorine atom becomes a chloride anion. Now there's attraction between these, a lot like between magnets. Remember that toy Magnetics, the little sticks and the magnetic balls? They don't sell those anymore because kids were choking to death on them. I have a big bin of them in my garage. When I'm unhappy with my children, I let them play with them. But you can imagine how this would work together with some sort of magnetic toy, right? So we've got the positive and the negative and the positive and the negative, and they're going to arrange themselves in this regular repeating pattern to maximize the forces of attraction and minimize the forces of repulsion. Because this green negative chloride ion is going to repel another chloride ion. And so you want the sodium ions in between, and they're attracted. Any questions? Those are ionic bonds. Covalent, the prefix co refers to sharing, right? Covalent is sharing of electrons instead of a transfer. So sharing electrons. Covalent bonds happen between nonmetals. Metals aren't good at sharing electrons, but nonmetals are. So if you have two nonmetals, like oxygen and hydrogen, bonding together, neither one of them is willing to give up an electron. They would both like to form negative ions if they could, but none of them wants to form a positive ion. And so instead of donating electrons, transferring electrons, they decide to share. That's what you do. If you have a toy and your friend wants to play with it and you're not willing to give it up, you share and you both play with it, right? So here we have the nucleus of one nonmetal and the nucleus of another nonmetal, and here's the electron that they're sharing. There's an attraction between the nucleus and this electron. And so if the electron's out here, this isn't going to be very stable. It's not maximizing the attractions. If it's over here, it's not maximizing the attractions. If the electron is right between these two and they're sharing it between them, that maximizes the attractions. And so that's a covalent bond where electrons are shared between two different atoms. And that creates a molecule. It's a lot like a superglue. Any questions? So covalently bonded compounds are called molecular compounds because they form molecules. In an ionic compound, there really aren't any molecules. There are ions, but they're just in a regular repeating pattern, and so we can't really say that there are molecules.